In this video, we'll see how we can get the formula for the area of an ellipse. We'll rely on the fact that an ellipse is a circle stretched in one direction. Let's denote the center of the ellipse by O, and let's put an xy coordinate system with its origin at O. Suppose that our ellipse intersects the x-axis at negative a and the y-axis at negative b and b. Then the circle intersects the x-axis at negative b and b. We stretched the circle in the x direction in such a way that this line segment of length b transformed into this line segment of length a, which means that a over b is the scale factor in the x direction. To see how this affects area, we'll first look at a rectangle whose sides are parallel to the axis. If its height is h and width w, then the area before we stretch it is w times h. And when we stretch it, height remains the same, but width is multiplied by the scale factor. So it becomes a over b times w, which means that the area of the stretched rectangle is a over b times w times h. But w times h was the area of the original rectangle. So the area of the stretched rectangle is equal to a over b times the area of the original rectangle. To see how this applies to an ellipse, we'll introduce a square grid. And we'll approximate the circle with squares that are inside the circle. When we stretch it, we get an approximation of an ellipse that consists of rectangles. Its area changed by the scale factor a over b. As we make the grid smaller and smaller, the approximation gets better and better, which means that the area of our ellipse is equal to a over b times the area of the circle. The radius of the circle is b, so the area of the ellipse is equal to a over b times pi b squared, which is equal to pi ab. That is the formula for the area of an ellipse.